Welcome to GG Dallas July 2021. I am proud to announce our speaker for the evening and introduce Moises Pedraza from Sngular. Apologies for not pronouncing that quite authentically. He's a front-end developer in love with clean code, good practices, CSS, JavaScript, and Dr. Pepper Light. Moises is a web developer who started his journey as a front-end developer when he was trying to share his illustrations to the world through a Geocities page back in 1996, before the dot-com bubble even started. He currently works as a senior front-end developer at Sngular. Take it away, Moises, and to tell us about TypeScript 101.
Thank you so much for the introduction, Luke. Well, yes, we're going to talk about TypeScript, and it's going to be an introductory tech talk. I prepared a small GitHub repo for you guys, so that way you can have the presentation there. It has the code for the small example that I am going to give you, but also it has inside the presentation, so that way if you feel that you want to remember something or you can find something useful from this one, you can have it there in this repo. I have just shared it in the chat. And let me share my screen. It's a pleasure to be here with you all. Sorry for all of these technical, but I mean, it's part of the fun. So here we are this is the topics that we are gonna cover. First, what is TypeScript? Then why do I want to use TypeScript in JavaScript? TypeScript basics, installing and using TypeScript, a live example app using only JavaScript. Then the important things to notice when we convert that one to TypeScript, we are gonna create a new project. That project is just a scaffolding, so you can have a playground to start getting your feet wet with TypeScript. Then I will share you some links where you can learn more about TypeScript, and also when you can contribute, especially with TypeScript documentation. That's open source, and it's great if you have some time and you want to be part of the community, you can go there and help. And finally, some question and answers. So let's start. What is TypeScript? Well, TypeScript starts way back. TypeScript is a typed superset of JavaScript, which means that it's built on top of JavaScript. You can picture it like JavaScript with superpowers. You can see it like JavaScript. JavaScript is awesome, so it could be like Tony Stark. But when Tony Stark used his Iron Man suit, that's pretty much the same. You are adding him more awesomeness and powers to the man. So pretty much the same with TypeScript, because when you start adding TypeScript to your JavaScript projects, you will start adding more features, but also more power to that. The best part, or at least what I most enjoy about TypeScript, is that it lets you catch the errors at a development time, not at runtime. And that's something really important, especially if you are building applications meant to be deployed into production. So that, for me, that's the best part of TypeScript, that it lets me catch the errors before I actually publish them. And how does TypeScript relates to JavaScript? Well, as I told you before, since it's a superset and it's built on top of JavaScript, pretty much every JavaScript code is compatible with TypeScript. So if you just have a JavaScript file and you change it to a TypeScript file, it will be running TypeScript code. It will throw you some errors, and that's good. That's something that we want, because that's part of TypeScript, that it will be telling us that you need to fix this and fix that. But it also adds new features to JavaScript. It adds types, which is the main purpose of TypeScript, and it also adds an extra layer of protection. The only caveat is that it needs to be compiled, but it's not that bad, because since it needs to be compiled, when you are trying to compile, if you have an error, it will tell you, hey, you have an error on this file, on this line, so you need to fix it before you can actually compile it to an actual JavaScript file. And that's pretty neat. Another feature, another cool feature that TypeScript have is that it will let you use ECMAScript 6 out of the bat. Well, right now, pretty much all the browsers let you use it. But if you are supporting some legacy browsers or older browsers, you don't need to use Babel. If you are using TypeScript, when you compile the code, it will compile it to just regular JavaScript. So you can just use it for your, instead of Babel, for using new features of JavaScript, and that's cool with TypeScript too. Also, guys, you can stop me at any moment if you have questions. So if you have some, please let me know. It's perfectly fine if you stop me. Now, why do we want to use TypeScript in JavaScript? And this is a pretty common use case. Usually when you are creating applications with JavaScript, you will be dealing with a lot of API calls. Usually you will have an object. In this case, what we are creating, it's a small function that accepts two parameters, the payroll and the incentives. We are getting those ones from the API. The function, the only thing that this function do is it's returning the sum of payroll and incentives. Since we were passing to that function the keys, the values of the keys that we have in that API call, it will be running, and it will be running fine because we don't have any runtime error in JavaScript, but we have a critical logic error because we are passing two strings, and when we are trying to add, what we are actually doing is we are concatenating those strings. So sometimes this is a really simple example, but when you are dealing with more complex applications, it's easy to get one of those kind of errors, especially since JavaScript have dynamic types. These dynamic types let you add these kind of things. In this example, I am doing two strings, just to be clear, but it could be one string and one number. So you don't have any runtime error there, but you have a logic one, and those are hard to catch. The goal of TypeScript is to be a static type checker for JavaScript programs. In other words, a tool that runs before your code run, static, and ensures that the types of the program are correct, type checked. So that's the major role of TypeScript, and that's, well, what I like more about TypeScript. At this point, do you have any questions? We're only introducing TypeScript. So now we will be continue with the basics of TypeScript. In TypeScript, we can add the types in different ways. What we usually do when we are working with TypeScript is we create our file. I am talking about just a regular vanilla JavaScript application, a small one that you are creating for just for fun. Because if you're creating enterprise applications and maybe you are using one framework there, you have pretty much all the frameworks and libraries there have his own TypeScript flavor. Angular was the first one, Angular 2, well, since version 2 was the first one to add TypeScript out of the box, but now you have versions of React that has, you can use create React app with TypeScript, you can use, you can create Vue apps with TypeScript, even Svelte ones, you can create it with TypeScript. But when you are creating just a small application, just vanilla JavaScript, what you usually do is you create a TypeScript file, just naming the file, for example, app, and instead of doing app.js, you do it app.ts, and that will be a TypeScript file. If you're using Visual Studio Code, this is especially friendly with TypeScript. TypeScript was initially developed by Microsoft, and since the beginning, Visual Studio Code was compatible with TypeScript, and right out of the bat, Visual Studio Code has a lot of linting and a lot of little snippets to help you develop with TypeScript. So that's pretty cool. In the beginning, way back there, when Visual Studio Code came, it was just for PC. So Mac users were complaining, so why we want to use TypeScript too, and we don't have those cool features. So another, well, not IDEs, but another programs start adding it. For example, Atom, and also Atom, I think Atom was the first, one of the first one to start adopting TypeScript. But in the end, Visual Studio Code came out for Mac, so now we are good. And pretty much all the IDEs and all are compatible with TypeScript. So what you need to do is just create one file and name it .ts. You will have right there your TypeScript file. And to compile it, you usually use npm, you will use Node, and you will download globally TypeScript. So it's just a matter of doing npm install -g TypeScript, and you will have TypeScript available. And when you want to compile your TypeScript file, what you will do is just write tsc space, the name of your file, and that's it. Don't worry, we will see that in later slides, but it's just for giving you some context. Once we have our TypeScript file, what we want to do is start adding types. TypeScript by default has types by inference. Remember that I told you that when you have JavaScript code right out of the bat was TypeScript compliant? That's because it will try to infer the types of the variables that you are creating. In this example, I have a const name and I am doing equal a string. So for TypeScript, when I'm assigning the value for the first time for that variable, in this case a const, TypeScript it's looking that it's a string. So starting in this case it's a constant, we are not supposed to change the value, but let's think that it was a let. So if I want to change name for a number for 14, since TypeScript from the first time checked that it was a string, it will throw you an error and it will tell you, hey, this const is a string, don't use a number, and it will not compile until you change it back to an actual string. For TypeScript, const name equal Moises, it's equal to const name colon string, which is the next thing that we are going to see, how to explicitly add types. In TypeScript, you can also add yourself a type to your code. The types supported by TypeScript are string, number, boolean, and array, which are just vanilla JavaScript, but it will, an array too, sorry, but it will add you more. It will let you add enums, enumerated values. It will add you void, and it will let you add any. It's not a good practice to use any, because if you're adding any to a variable, it's pretty much like adding a dynamic type. So pretty much like not using TypeScript. Sometimes when you start creating your first TypeScript files, you will be sometimes adding any, because TypeScript will be throwing some errors and you will be dealing, painfully learning how to deal with that, and you will end up writing any. Please don't use any. It's better to, since the beginning, start trying to look at the documentation and see which kind of type is, and start using that types instead of use any, because any is like a wildcard. It's telling TypeScript that it could be whatever value you want to throw there. So it defeats the purpose of TypeScript. And the way to actually explicitly add types to TypeScript code, to your variables, is using this syntax, using a colon after the name of the variable and then the type you want to use. If you do let current nickname colon string, and then you do an equal string Moises, that it's kind of a code smell. So if you're using a strict linter to TypeScript, it will tell you that you that please remove that part since it's being dynamically inferred the type. So you should use one or the other. If you are declaring and assigning the value, you don't need to define the type. But if you are just creating the variables, yeah, the way to go is just adding the type you want to use for that variable. In this example, I am adding three lets. One is current nickname, which is a string. The other one is a position, which is a number. And the third one is visible, which is a Boolean. For that one, I'm just assigning values. If I assign other values that are not matching the types that we are defining, TypeScript will throw you an error. Uh, TypeScript also support ECMAScript 2015 classes right out of the bat. So you don't need to use Babel again to start using this if you are trying to do support for older browsers. So TypeScript will handle this for you. And when you are creating a class, you can pretty much add types to everything that you are using there. We are creating the properties and we are assigning the values also inside the constructor and in the methods. In the methods, when we are creating methods, we will need to specifically tell what are we returning. In this case, in the toString method, we are returning a string, the name, the age, and the salary. If we are not returning anything, that's when void comes handy. We will need to tell that it's void and we are not returning anything. So we are adding strong types to JavaScript with the use of TypeScript, which that's a reason why not a lot of developers like TypeScript. It sometimes, well, they don't usually like to add those kind of types, and it will, in the beginning, it will be slower to start coding, but it will force you to code the right way because you can't use tricks to, you will need to code it properly. And the last one that we are going to see, and that's a feature that you will be using the most, it's the creation of interfaces. With TypeScript, you can create interfaces to explicitly describe a shape, for example, an object shape. After you create the interface, you can assign it to an object the same way you are assigning a type. In this example, I am doing it in the same place, but you can perfectly create your file when you have all your interfaces there and export them and then import that interface when you need to use that. In this case, I'm creating an interface student. That would be an object that has the keys name, ID, age, grade, and approved. So in my interface, I am telling the type of each one of those keys. And when I'm using the interface inside of an object, I just create my constant, in this case, max, and I'm adding a type of a student, which is the interface that I have just created. We will see that it will require us that have all of the values that we define in the interface. If not, it will be throwing an error. If you want to make one of those values optional in the interface, you can add a question mark before the colon on the key that you want to do it optional. For example, if you want to have a grade optional, you can do it just grade, question mark, colon, a string, and that will let you add or not add that grade to your object. They work pretty much like a schema here. All right. Any questions at this point? No? Well, let's continue. Let's see how we can install and start using TypeScript. I gave you a lot of spoilers in the beginning of the presentation. If we want to install TypeScript, first, what we need to do is we have to make sure that we have Node installed in our computer. If we don't have Node, it's really easy to install it. We just go to the Node page and download the installer, and that would be it. After you end up the installation, you will be getting npm with your node. So in your terminal, you will open your terminal and do an npm install -g TypeScript. This command is going to install TypeScript globally in your computer. Sometimes in Linux and in Mac, you may need to use sudo before the npm install. That depends on your settings. And then when you have your TypeScript already downloaded, if you want to compile a file, what you need to do is first create the new TS file, and then on your terminal, just write TSC, which means TypeScript compile space and the name of the file, in this case app.ts. Before it compiles, TypeScript is going to check if you have errors. If everything is okay, it will compile and generate a JavaScript file with the same name. In this case, it would be app.js. That file is the one that you want to import into your HTML file. So in your HTML file, when you are importing your scripts, you are not importing the .ts. What you need to import is the .js one, because the browser will not recognize that type file. That's the reason why we need to compile the TypeScript files into regular JavaScript in order to be available in the browser. Well, in the client, because you can use TypeScript in the browser for web applications, or you can use it with Node applications too. Now, let's have a live example app using just regular JavaScript. And this is the small applications that we are gonna use. This is an earning calculator here. We are gonna enter a base salary and a bonus, and we will get the total of that sum. So for that, this is just regular JavaScript, and the HTML is pretty simple. We have two inputs, type number, an ID, and a placeholder, and we have two buttons, one to get the total and one to clear. Is the size of the font okay, or do you want me to maybe make it bigger? All right, I assume that it's fine, but please let me know if you are not able to see it. Okay, let's open the inspect tool here. Here, this is a number field, a number input, sorry. So let's say that we get 500 bucks and a 25 bonus. We want to get the total. Here, what we are doing is we are using our total earnings method, which is this one. We are doing base salary and bonus. We are getting this base salary and bonus out of the input type number fields. But yeah, we are getting a total earnings of 50,025, because even though we are using number inputs, all the values that you get from inputs are strings. And that sometimes that happens really often. It's not only happens when you are dealing with API calls, but also when you are dealing with inputs. If you don't, you will usually want to do some error handling, and you will usually sanitize your inputs, and you will convert that into numbers. But sometimes it's hard to notice those errors. Here is evident because we are doing just two fields, and it's salary and it is bonus, and you will expect some value here. But when you are using more complex inputs, sometimes it's hard to notice these kind of logic errors. And that's valid JavaScript code. As you can see in the console, you don't have any error, because that's good. What we are doing is we are concatenating two strings. So usually what you may want to do is just debug the error convert your values into regular numbers, save, rinse and repeat. But for that, you have spent a lot of time debugging the error. And that's not good because you are catching errors at runtime and you don't want to do that. You want to be aware of errors before you actually have them in production. It's really scary when you are deploying an application that it's going to be for thousands or millions of people. And then you notice that some of your customers tells you that, hey, my app, it suddenly stopped working and I don't know why. And we just do A, B, C, D, E, F, G because they tend to do really strange corner cases that usually escapes from the testers and also from you. And then just you start to debug the applications and you notice that, oh, come on, this is throwing me a runtime error that it's stopping the JavaScript execution. And that's why the app is crashing. So in order to catch those errors that happens really often, you will want to make sure that you catch those errors, not at runtime, but when you are developing the feature. So how about if we use TypeScript instead of using regular JavaScript code? Well, for that, I have created an app.ts TypeScript file. It's pretty much the same code, but I have, for the sake of the time that we have in this tech talk, I have already added the types, but I can go and show you what are those types meaning. And if we change it for, instead of using JavaScript to TypeScript, you will see that right out of the bat, it's throwing me some errors. And the first one, it says that it is a conflict because another file, as you can see, it's using pretty much the same constant. And it's telling you that the file name is using JavaScript, yeah, the previous one. And it is because here we are using pretty much the same constant. So TypeScript, it's checking all your code and it's telling that another file, it's using the same constant and that you may need to change that because you don't want some name collisions in your application. It tells you not only the file, but the line of the code that you may want to change. In this case, since I copy and paste pretty much the same code, the error makes sense. So let me comment this guy out. I will need to comment all the code because let me just comment this line. And when we go here, we will see that pretty much all of these have the same error. And that makes sense because we are using the same code, just repeated in another file. So that's the first thing. TypeScript, thanks to Visual Studio Code, it's telling right out of the bat that you have a lot of code duplicate in another files, and it's telling you which files is that duplicate code, and then that you need to fix those errors. After you fix those errors, you will see that the code is good to go. So here, what we are doing is first, we are declaring all the DOM elements that we have on the HTML. We have a button. This is just a query selector that it's getting the ID of the button in order to be able to click it. Here I am telling with this bang operator, in TypeScript, I am telling, hey, I am pretty sure that this button exists and it's already in the DOM. We can use that when we have specifically typed the DOM element. If we have the dynamic DOM elements, I don't recommend you using the bang operator. That's only when you are creating the HTML the old way, that you are specifically creating these elements, so you are sure that they are already there in the application. Since I have created all of those elements, I am safe to use those. So I add the bang operator and I'm telling that I want to use this element as an HTML button element because this is a button. Add button and clear buttons are HTML button elements. Then we have two input elements. So we are telling that we are using base salary and bonus as an input element. And finally, we have our message box element, and we are telling it that it's just an HTML element. Since it's a P tag, we are telling TypeScript that it's just HTML elements. Then I have increased the security of our methods. I am telling that for base salary and for number, I need to pass, for these parameters, I need to pass numbers. So that way, and I am also telling that this method is returning me a number. So in this case, if we try to use it like we were using before and getting just the value from the input, you will see that TypeScript is going to tell us that we have an error. It tells us argument of type string. It's not assignable to a parameter of type number. And this is because TypeScript knows that the inputs value are always strings. It's trying to do, well, it's comparing the string that we're passing here with the type of base salary. And since base salary, it's a number, it's telling me, hey, you cannot do that. This is a number. So it's telling us the error right before it happens. And that's great. If we want to compile this code, let me just show you. Let me open a new terminal here. If I try to compile this code, I have to go to the location of the file to compile it. So here I'm inside the source folder, and we want to compile app.ts. So it should be tsc space app.ts. When we try to compile it, let me see if it. Okay, let me save it again. Okay, if we save it, it will work. I didn't save the file. Let me do it again. Now I save it. Now that I save it with the error, taking out the plus sign, it's telling you that it cannot be compiled. It's telling you that on app.ts, line 23, this one, we have an error. An argument of type string is not assignable to a parameter of type number. If we fix this error, it will tell us that we have another error before, and it will be pretty much the same. If we try to compile it, it will tell us that a string is not assignable to a parameter of type number. Once we have actually fixed that error, when we try to compile the file, that time it will work because we have fixed all our errors. And at this point, we will know that the code that we are compiling, it's good to go and we can use it because it doesn't have errors inside. We will see also here, if we open the files that TypeScript compiler generates, that it's changing all our ECMAScript syntax to all JavaScript syntax. All our let and const are changed to bar, and our arrow functions are changed to just regular functions. So it's doing pretty much the same work as Babel. It's compiling our code into just a regular version of JavaScript code. So that's another feature that TypeScript has. Yeah, and it has right out of the box. And finally, to use this file, what we just want to do is just go into our HTML file. And here, where I am importing the JavaScript file, instead of using the just JavaScript code, we are going to use the code that was generated from TypeScript, app.js, which is the compile code. And that would be working. that's one of, well, that's a lot of advantages of using TypeScript. That may not sound so exciting to Java developers or strong type use developers because they used to have those strong type languages, yeah, since the beginning. But for us that we have years using just JavaScript, it's, at least for me, it's really exciting to be able to have strong types that let at least my code be less prone to errors and also more scalable. This is the link of the, but I have already shared with you this link on the comments. So if you want to see the presentation or have a look at the code, and the same example using TypeScript is the one that I have already showed you. You can download this complete presentation from that GitHub repo. So important things to know is when we use TypeScript, it will let us know if we have errors directly on Visual Studio Code. It will not compile until we fix those errors. If we try to compile it, if we try to compile, it will tell us the error on the terminal. Once we fix the errors and compile the code, it will generate regular JavaScript code. We need to compile again our code if we make change to TypeScript to generate the JavaScript code again. And the compiled JavaScript code is the one that you want to import to your HTML. And this is pretty important. I cannot stress this enough because a common error is that it's trying to import the TS file into the HTML. That will never work because the browser or the client will not recognize that file. So it's really important. The name is the same, just change .ts to .js and you will be good. Because in the end, that would be the code that you will be generating when you compile the TypeScript file. And now, finally, we are creating a new project. This is going to be a really small project, and it's just an example of how you can start creating your TypeScript playgrounds. This is not by all means something that you want to use for a production-ready project. It's more something that you may or may not use for a proof of concept or just to toy around with TypeScript. So after the disclaimer, let's just have this step-by-step guide to create a small project. First, what we want to do is that we are going to create our project with NPM. We want to create a project using NPM because we are using NPM to manage our dependencies. What we want to do is do an NPM init, and it will ask us for some values. You can just press enter and you will be good. On the recently created project, we're going to add, it's not lit, it's light server. Light server is a small running server that let us run your application in your local host. But the cool thing about this lit server is that whenever you do change on your code and you save it, it will refresh the browser. So you don't need to refresh constantly the browser. You just need to just save and it will be refreshing the browser. If you don't want to add this package to your project, you can also use an extension for Visual Studio Code. I think his name is the same and it does pretty much the same. It just runs a local server. It just runs your project on a local server. After we add the light server to our dependencies, we create our first start script to the package JSON. So inside of our package JSON, we just add start and then light server. That will run the server to run our project. Now, after we have the initial setup, we can start adding up the HTML file and the new app.ts file. Inside the HTML file, we are going to import the compile.js inside the index, and you will want to import pretty much the same name as the TypeScript file you have, but with a JS extension. at this point, we can start adding the content. What I usually do when I am creating the scaffolding of any project is I check that the wiring is correct. So I usually just add console logs to see that everything is connected before I start adding code. Because in the initial stage, it's easier to catch if everything is wired. If you start adding code and methods and whatsoever, it can be harder and you can start adding complexity. So it's better to just test your wires using simple console logs. After you have created your file in the terminal, you can compile your TypeScript app. And after the compiler sends, since we are using the light server, you do an npm start and you should see your page in the browser. You will end up with a link in the local server running in your terminal. And you can also, the terminal will try to open your browser, and depends on your settings, it will let you open a new browser window and run your project by your own. But we have a small caveat. Every time you save the TypeScript file, you will need to stop the execution of the server and compile the TypeScript again, because the light server doesn't help you compiling the TypeScript one. You can automate this process using Webpack or using Gulp, but that would be my next tech talk. So sorry for that, guys. And if you want to start toying with a more robust solution, you can start creating a React app with just create React app, and you can add the flag of template TypeScript, and it will give you a TypeScript version of your project. And or you can just use Angular and create a new application, and you can start having TypeScript right out of the bat. Now, do you have any questions at this point? All right. Well, let me tell you a little bit about my experience with TypeScript. I tried to learn TypeScript way back when I was still living in Mexico. I was working for BBVA, and I was making a small proof of concept for an online banking flow. We were trying to use, not React, we were trying to use Angular, but because at that point of the story, it was, I think, 2015, 2016. I don't remember exactly the year, but I remember that React was having some hate by the followers because they're trying to change his license to something more private. That license thing in the end backfires React and gives Vue a lot of exposure because all the people were trying to look for alternatives to React. In the end, React just tell the people, hey, we are not going to change our license. It will be continue to be as it is, so you can still use React, but the damage was done. That was the reason that, at least in BBVA, we skip using React. So we start toying with Angular. At that point, it was Angular 2. And that is my first approach with TypeScript. I start using TypeScript as it is regular JavaScript. So I start learning it. And then I realized that the messages that it was giving me, they were helping me. So that's when I start trying to learn and get my hands deeper in TypeScript. At that point, the documentation was not nearly as good as it is today. Today, TypeScript has a great documentation because it has, well, it has a lot of topics that let you choose for what are you want to use TypeScript. You can use TypeScript for JavaScript. You can use TypeScript for Node. You can use TypeScript for another language. So it will lets you choose which flavor of TypeScript do you want to use. And it will give you guides, and it will give you a handy handbook that you can read it completely in 30 minutes. So it's a great investment of your time. You can just go to the documentation, check the handbook, and you will be able to start working with TypeScript. It's really easy to start with TypeScript, but it's kind of complex once you start learning it. because you will pretty much anything. You will find that you have a lot of options, and then you will try to to use those options, and then you will try to improve those options, but those are paths that will start to open to you. So at that point, I start trying to take TypeScript more serious, and that's helped me a lot, because in the end, we gave that proof of concept that was not approved. Then we continued using some a framework that was custom developed by BBVA. But nowadays, right now I am working at PNC, and in PNC we're using Angular 8, and we are using the strict version of TypeScript. And the strict version of TypeScript, it's really cool because it catches pretty much all of the errors before it goes into production, but it's really tough to understand. Sometimes it gives you a lot of headaches. So my recommendation to you guys is, if you download Angular, once you run the application, it will ask you, do you want to go easy, or do you want to taste the real deal? Just choose the real deal, because in the end, that's the experience that it's more close to the ones that we are using in enterprise. And also it's a great way to learn TypeScript, because you have all the tools available. All the errors will be pointing to you if you're using Visual Studio Code, or if not, you can just search it, and TypeScript has a huge community online. So pretty much anything error that you will get, someone that error happens to someone else. So if you just Google that error, you will find a lot of Stack Overflow answers for your questions. But the more you use TypeScript, the more you realize that it will give you more order into your code, and more error prone, well, and more cleaner applications. Sorry. So that's it, guys. This is the links that I have added here to you. So you have here the link to start contributing to the open source documentation of TypeScript. You have a TypeScript for JavaScript developers. That it's really easy and has some tutorials. The TypeScript handbook, which is my recommendation, please just go and download that handbook or just read it online. And the TypeScript playground, it has a lot of examples there, so you can just watch the examples, code along the examples. And that's it, guys. Q&A.
There's a question in the chat. So they were asking, I noticed you added a plus sign to the variable name in that example you were debugging. Does that convert it to a number?
Yep, that convert the string to a number.
I'm curious, why would you do it there and not inside the function that you had, or method, or whatever you want to call it?
Usually in real life, we do it inside the function, not right there, not when you are invoking the function. What we try to do is just get the values there and convert it to the type that we need to use. Yeah, that was just for the purpose of the example.
Just to show the
advantages of TypeScript. Yeah, but that's a bad pattern. You will always try to do it inside the method, not when you are calling it.
I posted a link from MDM. I was wondering the same thing, and so I looked it up.
Nice.
Yeah, that was definitely a quick hand, shorthand notation I did not recognize of casting the integer, but I'm also not a web developer, so I didn't want to think. So I'm not surprised that if I'm confused. Cool.
Oh, hope you have enjoyed the presentation, and also you can reach me if you have questions or comments, and you have this presentation and the code available in the GitHub repo that I have already shared to you guys. It was my pleasure being with you today. Thank you for your time.
Thank you very much, Moises. That was great.
Yeah, good job.
My pleasure.
One quick
Round of
housekeeping.
applause. Sorry.
Sure.
Could you make me a host or co-host on the meeting? I was trying to help you get screen sharing, and I was like, well, maybe I need to make him a host. Turns out that removes me from being able to be a host. So if you go to the participants list, which if you stop sharing, it becomes easier to find this.
Okay.
I'm going to edit all this out of the video. Don't worry.
Now, just let me see how can I stop sharing. Okay, it should be this red button, stop sharing.
Yeah.
Thank you.
Now at the bottom, there's a participants.
I
button.
saw you. Yeah, participants.
And then if you go over to my name in the list and hover over it, a more button will appear. And I think under more, it has a make host button.
Yep. I have made you a host.
Yay. Now the recording is moved over to me. That's weird, but that's how Zoom works. So I can always edit this section back in. So all I'm going to say, did anybody else have any questions for Moises? A couple of comments in the chat from people that are too scared to talk, I suppose. Joaquin, who's always good for a chat, said, great, thanks, Moises. I think we can all echo that. And Rajesh said, TypeScript popularity is rising, which, and then he posted a link to some Stack Overflow information, which I would totally understand because type safety is a huge deal. And also, if you've ever seen the JavaScript what video, yes. It's pretty good. It can be very confusing, and it will pick weird defaults, and so you can get very odd behavior. So TypeScript, I can understand, feels a little safer.
Yeah, it gives order and tranquility to the JavaScript ecosystem.
Yeah, compile time checking alone is just having some idea that maybe you didn't mess things up unintentionally.